Okay, so for this first problem, we've got an element reacting with a compound. The only time that happens is for single replacement. Okay, so I can identify my type of reaction with single replacement. In single replacement, we're going to have an element reacting with a compound, and the element switches places with something in the compound. So we identify the fact that calcium is a cation, and iron's a cation, and nitrate's an anion. Because calcium is a cation, I know it's going to switch places with iron, also a cation. And so now iron is going to be by itself. You can write iron, or you can write iron Roman numeral 2, it doesn't matter. And then calcium and nitrate are going to be together now. So I'm ready to write my formulas. Calcium by itself is just calcium. It's just Ca. Then iron 2 nitrate. I think about my charges. Iron has a positive 2 charge. Nitrate is -1. Over here, iron's by itself, so it'll be normal. Calcium is positive 2, and again, nitrate has a -1 charge. So I can write my formulas. FeNO3 2. Remember, we use parentheses when we want more than one of a polyatomic ion. Then iron is our product by itself. It's just Fe. And then we've got calcium nitrate. Calcium is positive 2. Nitrate is -1. So I need 2 nitrates. So looking at this, I've got 1 calcium on the left, 1 on the right, so that's balanced. 1 iron on the left, 1 on the right, so that's balanced. 2 nitrates here, 2 nitrates here, so that's balanced. That question is done. I do not need to use any coefficients. Okay, looking at our next problem, we've got sulfuric acid reacting with magnesium hydroxide. The word acid indicates that I've got an acid. And the word hydroxide is indicating that I have a base. And as soon as I have an acid and a base, I know it's neutralization. Neutralization will not be on the quiz tomorrow in terms of predicting products, but you do need to be able to balance it. So for a neutralization, one of our products is always going to be water. And then your other product is the cation from the base, so magnesium. And the anion from the acid. Sulfuric came from sulfate. So I think about my charges here. I know hydrogen is +1. Sulfate is SO4 -2. Magnesium is +2. Hydroxide is -1. Over here for neutralization reactions, we write water as HOH. And again, that was just to help us when we do our balancing. So we write our formulas, H2SO4, magnesium hydroxide, water, and magnesium sulfate. Okay, like I said, I always like to start with polyatomics. 1 sulfate here, 1 here, so that's balanced. Magnesium, 1 here, 1 here. That's balanced. So now I look at hydrogens and oxygens. I've got 2 hydroxides on this side, 1 over here. So I'm going to apply a 2 coefficient. Remembering that that 2 gets distributed to both the hydrogen and the hydroxide. So now I have 2 hydroxides, which I wanted, 2 hydrogens, 2 hydrogens. So it's balanced. Iron 3 acetate plus cadmium. So I've got a compound and an element. Single replacement. When that's the case, I identify the element by itself. It's a cation. Because it's a cation, that means I know it's switching places with the other cation. So now cadmium is with acetate. and iron is by itself. So iron is +3, acetate is -1, cadmium by itself is just cadmium. Cadmium in a compound is +2, acetate -1, iron by itself is just iron. So we're ready to write our formulas. We've got Fe, C2H3O2, then we need 3 of them, plus cadmium by itself, and then cadmium with acetate, and iron by itself. So then we need to balance. I forgot the 2 here. There we go. Looking at this, I like to start with my polyatomics. I have 3 over here, 2 over here. So we come up with the least common denominator, which is going to be 6. And so in order to get 6 acetates on this side, I need to use a 2 coefficient. And in order to get 6 acetates on this side, I use a 3 coefficient. So now my acetates are balanced, and I've messed up everything else. So that 2 went to the iron also, and so I have 2 irons over here, 1 right there, so I put a 2 coefficient. Cadmium, I have 3 here, 1 right on this side, and so I put a 3 here, and now we're balanced. All right. Octane plus oxygen. All right, so octane, and I give you the formula, is a fuel. The only type of reaction that uses fuel is combustion. And the nice thing about combustion, your products are always the exact 2 same things. Carbon dioxide and water. Every time. Okay? And so the only thing that's tricky about writing this problem is paying attention to remember that oxygen is a diatomic. It's easy to forget that. So I'm just going to go right into writing formulas. C8H18 is given to us in the question. Oxygen is a diatomic, so it's O2. Carbon dioxide and water. Here we can just write water as H2O because we're not dealing with hydroxides, so it doesn't matter. Things to keep in mind when you're balancing your combustion problems. When you do these, we're going to do hydrogen first, then carbon, then oxygen. And you can keep a little checklist if you want on the side. So, first we need to identify how many of each element we actually have. 8 carbons, 18 hydrogens, 2 oxygens. On this side, 1 carbon, 2 oxygens, 2 hydrogens, 1 oxygen. All right, I'm actually going to list those all in one column. I think that's easier for combustion problems. All right, so combustion, hydrogen first. 18 on this side, 2 over there, so I want to put a 9. Remember the rule for combustion, no odd numbers for water. So because I want to put a 9, I double it, and I put an 18. That 18 goes to both the hydrogen and the oxygen. So now, instead of having 18 hydrogens, we're going to multiply it by 2. And so we've got 36 hydrogens and 18 oxygens. So hydrogen is still not balanced. I need to put a 2 over here. So that's going to change my hydrogen to the 36 that I wanted. And it also changes carbon now to 16. So hydrogen is good, 36 and 36. So I need to get 16 carbons on the left. I have 16 carbons on the left. I have 1 on the right. So I apply the coefficient 16 here, which goes to both the carbon and the oxygen. So carbon becomes 16, oxygen becomes 32, and my carbons are balanced. And so for oxygen now, what we do is we total up the number of oxygens we have. So we have 32 and 18, which gives us 50 oxygens on our product side. So we have 50 on the product side, 2 on our reaction side, and so we use a coefficient of 25. nickel 2 cyanide and aluminum phosphate. When you've got a compound reacting with a compound, that's going to be double replacement. So again, you have a choice. You can either switch the two cations or switch the two anions. It's whatever you want. I like to switch my cations. So I end up with aluminum cyanide plus nickel 2 phosphate. Then we go in and we write our formulas. Nickel's +2, cyanide is -1. Aluminum is +3, phosphate is -3. Aluminum is +3, cyanide is -1. Nickel is +2, and phosphate is -3. Then we just balance polyatomic ions first. 3 here, 2 here, least common denominator is 6. So I'm going to put a 3 here and a 2 here. That 2 made it so I have 2 aluminums on this side, but I only had 1 here. So I apply a 2 here. So 2 aluminums, 3 nickels, 3 nickels, 6 cyanides, 2 phosphates, and 2 phosphates. So it's balanced. All right. Barium oxide, an individual compound. That tells me it's decomposition. In decomposition, our compound splits into its ions, into its elements. So we have barium plus oxygen. Okay. Barium has a +2 charge, oxygen has a -2 charge, so it's just BaO. Barium by itself is just Ba. Oxygen, ding ding ding, diatomic. All right, O2. So then we need to balance it. I've got 2 oxygens on the right, 1 on the left, so I need to apply a 2. Now I have 2 bariums on this side, 1 over here, so I apply a 2 there, and it's balanced. Our last problem is this rubidium and chlorine. When it's an element plus an element, that's going to be synthesis. Remember, you can also call it combination. Either one is fine, whichever you prefer. So rubidium and chlorine are going to combine to make rubidium chloride. Okay. Rubidium by itself is just Rb. Chlorine by itself, diatomic, is Cl2. Then for our compound, rubidium is +1, chlorine is -1, RbCl. So then we just need to balance it. 2 chlorines right here, 1 on the product side. So we apply the 2 coefficient, remembering that the 2 goes to both things. So now I have 2 rubidiums on this side, so I need to apply the 2 coefficient on that side. And that's it.